Well, a very good morning and good afternoon to everyone who is joining us from Asia and from Europe. We're so glad to have you for this discussion on explainable AI. I'm Cal Joff, and I'll be helping moderate today's session. This discussion today is part of a series on regulating AI, artificial intelligence, debating approaches and perspectives from Asia and Europe. Now, today we're going to be focusing on a critical challenge in artificial intelligence. AI systems are often opaque. Frequently, we don't understand how they came to the recommendations that they make, what assumptions that they're based on, and what is the logic connecting really what goes in to what comes out, and what makes AI this technology that promises to be at the center of our lives, not just in consumer products, but in healthcare and government, difficult to trust, right? And so if we don't understand AI and how it is producing results, it also becomes challenging to understand what are some of those biases or weakness of those systems. How can we make use of it in policy and government and in all kinds of different sectors in society? And a lot is at stake here, because just in these early days of seeing AI applications scaled up, we've already heard stories of AI systems being biased and including biases against underprivileged groups. So we have this fascinating emerging area of explainable artificial intelligence, a trustworthy artificial intelligence that is coming out. And that's going to be a big focus of our discussion for today. All of this is designed to foster public trust, effectiveness, and fairness. But before we get into that discussion, I'd like to talk a little bit about who is co-organizing today's session. So the Heinrich-Böll Foundation, or HBS, is the Green Foundation from Germany, linked to the German Greens. And it's dedicated to dialogue and exchange between Asia and Europe on themes of common concerns: sustainability, energy policy, environmental protection. HBS works in Germany with its headquarters in Berlin, as well as 35 offices all over the world, including the office in Hong Kong, which is co-organizing this event. The other co-organizer is the Association of Pacific Rim Universities, or in short, APRU, which is a network of 60 leading research universities that was established close to 25 years ago. And so the APRU network brings together university leaders and scientists to collaborate with policymakers, industry, foundations, multilateral organizations, to collaborate on all kinds of practical solutions to challenges in the Asia and Pacific region. It's a policy dialogue kind of platform. Now, the APRU Secretariat is based in Hong Kong, and its member universities are located in 19 countries across Asia, Southeast Asia, Australasia, North and Latin America. So if you're going to post some things on social media about this event, do tag HBS and APRU on them. Let's talk a little bit about who's here today. Joining us, we have a fantastic audience from all over Europe and Asia Pacific. We've got policymakers, we've got academics, researchers, and interestingly, also a number of people who have joined us from civil society organizations. And of course, we have our panelists and our speakers for today. So we have Professor Matthias Kettermann. He's the head of the research program at the Hans Bredau Institute in Germany. And he's a professor of innovation theory and philosophy of law, and the head of department for theory and future of law at the University of Innsbruck, Austria. We have Professor Liz Sonnenberg, who is the Pro-Vice Chancellor for Systems Innovation at the University of Melbourne in Australia. And Liz is also a member of the advisory board of AI Magazine and the standing committee of the 100-year study on artificial intelligence. And then finally, we are joined by Dr. Brian Lim. He's assistant professor of computer science at the National University of Singapore. He leads the NUS UbiComp lab that's focused on research on ubiquitous computing, explainable artificial intelligence for healthcare, wellness, and smart cities. So just a few notes as we start. Number one, today's session is recorded. Two is we had a very active conversation in the chat in our last session. So I really encourage everyone to post your thoughts and questions into the chat, or you'll see at the bottom of your screen, there's the Q&A button as well, so dedicated for questions. And I'll be looking out for some of those questions as we go into the conversation. So feel free to post questions anytime. I'm going to keep on watching those two areas. Now, to help us kick off the conversation, I mean, perhaps we can start with Professor Sonnenberg. Professor Sonnenberg, why do we want AI to be explainable to society? And really, why are we here? What's hard about getting to explainable AI?
Well, thanks, Carl. Thanks for the introduction. And as you've noted, in the past few years, AI has very much left the laboratory and entered our everyday lives. There are many stories of AI success, but algorithms are trained with data sets and proxies, and developers too often and unintentionally use data sets with poor representation of the relevant populations, and so their outputs of their algorithms are biased. Some of you may have heard of the system Compass. This is a software tool that's used across the US justice system to predict the risk that a criminal defendant will reoffend. Advised by the scores generated by this software, a judge will decide whether or not to detain the defendant prior to trial. The algorithm for Compass is proprietary and secret. The input used for prediction uses 137 different factors: age, gender, criminal history, and other matters. It does not use race as an explicit feature, but there's a lot of analysis, published analysis, that suggests that the algorithm operates in a racially biased way. So derived properties from these 137 possibly neutral sounding characteristics turn into potentially biased analyses. Now, the owning company disputes this, but nevertheless, there's quite a lot of literature around it. As a simple example, it's argued that Black offenders are almost twice as likely as white offenders to be labelled by the system as a higher risk, but actually not go on to reoffend. So these kinds of analyses lead us to questions of fairness of algorithms and how it should be defined and assessed. But I've been asked to talk about explainable AI, or XAI for short. That's an umbrella term for the various techniques that are being trialled to enable AI applications to provide outputs that enable humans to understand why the system has made particular decisions. So I'll briefly comment on the what, the why, and the how of explainable AI, and along the way point to some aspects that my fellow panelists will elaborate on. So first, the what. And let me start with a very simple example just to make it concrete. Consider a credit scoring application that interacts with a consumer whose loan application has been refused. An XAI-enabled system would not only provide the recommendation, but would enable the customer to ask the system, what could I do differently to get a positive outcome? An XAI system might draw on the internal parameter-driven decision-making to compare the profile of the customer with those of customers with similar but different attributes, and then might respond, well, you're currently holding 3 accounts with a cumulative debt of, say, $5,000. If you consolidated the accounts and repaid half the amount, then the loan would be approved. And yes, that's an overly simple example, but perhaps is enough to have you appreciate that more sophisticated XAI could enable various stakeholders in the system application and adoption to better understand why a prediction is made, and in doing so, increase user trust and hence increase AI adoption. And importantly, XAI is more than just an optional extra. As you'll hear more about from our second panelist, Matthias Kettelmann, European legislators are seeking to restrict applications of AI, which will further drive the need for insight, transparency, and governance. And as you've asked, Carl, generating useful explanations is a very hard problem, and I'll just briefly comment on 3 facets of the difficulty. First, there are major technical challenges. Machine learning systems can be difficult to comprehend even by the developers of those systems, as you hinted at. Compass, that I mentioned, uses 137 parameters, and that's deemed to be complex, but systems can actually be built with thousands and sometimes millions of parameters. And so it's virtually impossible to derive precise reasoning from such models. And machine learning, of course, isn't the only form of AI technology in use, but even rule-based systems that seem to lend themselves to explanation generation more naturally because they're encoding knowledge in some way, are also not able generally to be able to generate useful explanations. An audit trace of the rules that are applied to arrive at a decision is not generally meaningful to a user, and finding ways to abstract the information meaningfully is hard. XAI technologies are being actively researched, as you'll hear, but the field is relatively immature. The second difficulty sits around the human experience of what it means to provide a good explanation of some complex phenomenon to another person. As the explainer, you have to not only understand the rationale for the decision, but you need to be able to understand what the other person already knows and doesn't know about the situation, provide appropriate information at an appropriate level of detail, not too simple, not too complex, and then be able to elaborate with more information on request. And you'll hear more from our third panelist, Brian Lim, about what it takes to develop high-quality machine-generated explanations. And the third difficulty sits around the deployment of such systems. Having highly trained professionals in any field adopt new technologies is a socio-technical challenge, and it's not unique to AI systems. There's a vast literature on intelligent decision support systems and human systems engineering that demonstrates that the way in which information is presented to the decision makers can have a significant effect on performance. But even when systems are highly accurate and their performance exceeds that of human experts, because the internal decision processes are not inspectable or explicable, the human decision maker may or may not have confidence in the system's advice for good reason or otherwise. And so paradoxically, the human whose objective performance may be less than that of the AI software is a gatekeeper that, for good reason, perhaps is preventing that software from being used. And arguably, XAI is one key to bridging this gap. So the successful adoption of AI applications, particularly in high-stakes settings, oversight is necessary to ensure there's responsible, ethical, and fair practices in place. The ever-improving technical capabilities of AI are a double-edged sword, but I at least am optimistic that the positives will outweigh the negatives and that XAI will be an important element in achieving progress. So I hope that begins to answer your questions.
Fantastic, and thanks so much for laying out those three challenges, and also just how high the stakes are. Right, we're really hearing that already some of these systems have life altering effects and sometimes in very problematic ways. I'd like to turn to Professor Ketterman. Professor Ketterman, you've been working on a large explainable AI project over the past 5 years. Can you tell us a little bit about what you're learning from that could help us inform how we make policy around explainable AI? How do we ensure that this gets implemented and designed well? And you've been watching some of the sort of policy moves in the EU around this. How does what you think ought to be happening compare to what is happening when it comes to the EU's policy moves on explainability?
Thank you so much for having me. To your first question, indeed, we've been working on a number of projects dedicated to finding out how to best explain AI-based decisions. What we noticed right away was that it's not a good idea to leave the design of those explanations to either lawyers or tech people or decision and program and designers. What you have to be aware of is that explanations are extremely challenging to design well and to implement well. Just ask yourself the question, if you take a decision, how do you explain that decision? Is it actually what your reasons are, or is that what you think your reasons might be? And then you have to transpose that to a system. So obviously it's going to be difficult. So what we need to make sure is that any approach to designing explanations for AI-based decision-making is an interdisciplinary endeavor that includes law, tech, and includes also design thinking, because obviously we have to think about what kind of information do people need, right? They don't actually need to know all of the parameters. They need to know how they could change their behavior, or what aspects of their behavior or of the data which was available for them influenced the decision, and whether they can do anything about that. That's the information they actually do want to have. And indeed, we are increasingly seeing the importance of the underlying right to explanation. We all have a right to justification if an entity, be that a state or a machine, influences how we live our lives, influences the way that rights and goods are distributed among individuals and among societies. This right to justification is implemented through partially through explanation of AI-based decisions. We're only seeing the very first steps globally towards the implementation of that right, and I believe it's one of the key challenges of the next years to make sure that people are not do not feel powerless against towards AI-based decision, because that breeds distrust and insecurity. Coming to your second question, this is sort of in the background of quite a number of normative approaches, of legislative approaches taken by the European Union. Chief among them, of course, is the AI Act, but I don't think we should talk too much about that. It's a very detailed act. It has the different risk categories. It's extremely interesting. But if you look at the explanation dimension, I think this is where we really see advances happening. And the advances are ironically not in the AI Act, but rather in accompanying acts that impact platform governance more broadly. So, for instance, in the most recent Digital Services Act, there are clauses. That's a European act that defines certain rules for online platforms, for digital services providers. You know, think everything from Google to Meta to Twitter to TikTok. Those companies are obliged to provide insight into the logic of the recommender algorithms they use. And I think that's a huge step. Up to now, states said, okay, you have to delete illegal content, but what you do with non-illegal content is basically up to you. You know, it might be lawful and awful, but you can use your own algorithms and recommend something and make other things disappear. This has led to phenomena like disinformation. This has enabled crime, certain kinds of crime online to persevere. And I believe this trend towards ensuring that people know more about how platforms operate through a duty to have more information about recommender algorithms is the first step towards a more law-based platform order. And I'm very happy to engage on that question also with the audience. Thanks.
Thanks so much, Professor Ketterman. And I just wanted to ask a quick follow-up on that. So the rights and the duties that you have mentioned, do they already exist? Are they already inscribed into law, or are these things that you think ought to be put into place?
Thanks for the excellent follow-up. Partially, they are already in law. And so, for instance, in the General Data Protection Regulation, there is already now a duty for those who have automated decision-making engines to provide people whose data is used in those processes automatically with an explanation about the logic of the underlying algorithm. This is not implemented all the time because there's a small get out, because if you include a human somewhere in the whole process, this absolves the people using the AI-based decision-making engine of that duty. But it is already in the law, but the majority of new clauses are going to be coming to 2023, 2024.
Fascinating. Thanks so much for sharing that. And I think we'll definitely want to come back to this. Dr. Lim, coming to you, one of the three key challenges that Professor Sonnenberg mentioned earlier was the human experience of what it means to provide a good explanation. And now I know a focus of your work is in cognitive psychology and perceptual processes. What are we learning from that? What are you learning from that can help us inform how to build quality explanations, or at least how to design systems that can give us quality explanations?
Thanks, Carl, for the opportunity to answer that question. So yeah, my research is in human-computer interaction, and we build technologies that are usable for people, right? And given how prevalent AI is and how important it is to provide explanations, we now look at that as a usability problem, right? At a high level, you can think of it as this: is we delegate duties to AI, right? And if we delegate it to a human, they have to justify their reasons. So we are looking into how can we get the AI to generate their explanations the way that a human would. So I have a few slides that I like to share that can help to clarify a bit of what we've been up to. So here's just an example of a medical doctor or a model of one, but let's consider a medical application, right? That's going to predict whether a patient has a high mortality probability or low, right? Whether the patient is going to die. And so the AI predicts this and the doctor says, oh, that's nice to know, but are you sure? Like, why did you make this explanation, this prediction? So it can then generate this as an explanation, and this is quite state of the art now. This is using a method called LIME. And on the left here, though, you see it uses decision rules, and on the right, it says which of these rules or features are more important, right? And these are not important, these are very important. So these are what the machine learning scientists and engineers are coming up with. But think about this from a medical doctor, right? They're very smart, but they go through and understand biology and human disease. Do they know how to interpret these explanations? Is this how they share explanations with one another? No, they think in different ways, right? Despite that, there's been plenty of explainable AI algorithms that's been developed in the past few years, right? And you can classify them as these different fundamental approaches to understanding. But it's getting very messy. And I was wondering, why do we need such a diversity of explanations, right? And for that, we turn to human psychology and philosophy. So here, by understanding people and by understanding what are the reasoning processes from philosophy, right, regarding how people think and how they explain to one another and how they actually think, from theories in psychology, we can then inform how we should be designing explainable AI, right? So it's not just that the scientists are so smart and they come up with all sorts of arbitrary explanations. It should be guided by these underlying reasoning processes. So from here, we can then identify how people should reason and explain to each other and how to generate explainable AI to satisfy those needs. We also learn about how humans actually reason. So we're not perfect in our decisions. We try to be efficient instead. And with that, we suffer from cognitive biases and we make decision errors. So then we look into how can we use explainable AI to mitigate those errors, right? So with that, the AI and human working together, they're able to reduce their decision errors and make better decisions. And here we're able to then tailor how specific explanations can augment or enhance human reasoning. So you have a lot of details in the paper if you want to see. There's a lot of difficulty with how to do this, and our paper goes into some details of how to make those connections. So this is one example where understanding how human thinking can guide how we should design explanations. I'd like to also introduce another example here. So let's say we have, Amazon Alexa that listens to our voice and it can predict our emotional state and maybe recommend the right music for us. So let's hear this example.
Dogs are sitting by the door.
So in this case here, we have an AI that predicts that voice sounds particularly fearful, right? And so imagine if you're going about your day and it predicts this, you wonder, why do you think I'm fearful today, right? So you may ask that question and say, here's an explanation for that, right? So I understand a lot of you may struggle to understand what does that mean, right? It's a complicated diagram. It's formally known as a spectrogram. And if you have training in electrical engineering, you'd understand. It shows you how frequency changes over time. And then we show a heat map over that, right? So this is a rather technical but popular method that a lot of scientists have developed to explain AI. But obviously, this is not good enough for your lay audience, right? So currently, explainable AI lacks human interpretability. In general, they're too technical, they're not relatable, and they're not human-like. And this tends to happen when engineers or scientists develop applications for end users, right? So XAI is a pretty new field, and it's being led with a very technically minded community, and so they still suffer from this. But hopefully things will get better over time. So I argue that explanation should be relatable to the concepts that we know, to the examples that we're familiar with, and to certain cues or related information so that we can make sense of how the machine is thinking, right? So this is a nice collection of ideas here. But then I asked further, why do we as humans care about this? And once again, I turned to human psychology to understand this. And from that, we identified the theory of human perceptual processing, right? That guides how, given a stimulus, we process the information in a certain way, and then we interpret it. So from there, we are inspired to create the XAI perceptual processing framework. And let me tell you how it works. You imagine that you look at a scene. In this case here, I'm not going to describe what it is yet, right? So that's a stimulus. And then our brain actually selects certain parts about it, not everything, right? And from that, then we look at certain shapes and we say, hey, I know what that is. That's an ear, that's an eye, that's a nose, right? So our brain is organizing that information. Then after that, it goes into the interpretation phase, where it's able to recall certain related information. So let's say here, a cat and a dog, and then it says, well, let me recall what the ears or eyes or nose of a cat or that of a dog looks like. And then let me compare what I see to what I remember. And then I realize that it's closer to the signals for a cat. Therefore, I conclude that I can categorize what I'm seeing as a cat, right? So this is a demonstration of how the human perceptual processing works. And then we look at that and we think, can we get the AI to process like that too, right? And indeed, we realize that there are existing technical approaches that line up with some of these steps here, right? And with that, we're able to then develop this complicated deep neural network here. Don't worry, but this is what the machine learning engineers would do. But over here, we're able to modularize it and say it has components that satisfy the specific explanation objectives, right? So here we can say this part plugs into that, and this information plugs into the next step, and so on and so forth. So this now we have an architecture that is interpretable by design, right? And we can say that this thinks like a human. And by designing AI or AI explanations that are human-like, we aim for the users to trust the AI more because it is just like us. So in conclusion, I argue that it's important to, it's important to consider explainable AI from the human psychology point of view, and also what is technically possible with AI, and combine them using HCI techniques so that we can bridge between the two fields and develop explanations that are more human-centered, that real people, whether you're lay users or a domain expert, can interpret, and then you can truly trust and delegate more duties to AI. Thank you.
Excellent. Thanks so much, Dr. Lim. And I'm going to go to some of the questions that we have coming into the chat already, because we've got some really interesting ones. And one of them, I think, gets to the heart of kind of what is an explanation. So what I find so fascinating about this discussion so far is that these new technologies are forcing us really to return to first principles around philosophy, how we think, how we reason, and so this is just very interesting. But to Professor Sonnenberg, we've got Rita asking, in empirical research that she has done, XAI in healthcare, they found that clinicians and patients don't really want technical explanations on how, for example, an AI diagnostic tool has made a decision. What they want to know is it accurate? Is it approved by regulatory authorities? Is it clinically tested? And so I guess my question here would be, when we talk about an explanation, especially an explanation that is geared towards strengthening trust, what do we mean? And is it something that is needed, for example, in these healthcare settings?
So I think there are two parts to this question. There's, what does the clinician need in order to be able to take advantage of the analysis that the AI algorithm has provided as value add to an image or a set of tests? And what does the patient need? And I think they're different answers. The use of I'll give a very simplistic view of what a clinician does. A clinician is synthesizing a blend of raw and processed data. It might be test results and a variety of other inputs, what they know about the patient history and so on. And they bring their expertise to create a conclusion in that context. And often it's not a sole decision by a clinician. It might be a group of just clinicians with complementary expertise and so on. And on top of that, there's extensive training, extensive debriefing, and so on. What the XAI approach does is provide a form of a bridge between the very raw data and the process data, and allows a clinician or a group of clinicians to drill down to understand what sits underneath the recommendation, which they then subsequently will apply their expertise to synthesize with other information and then abstract that appropriately to the patient. So the role of XAI is to support the confidence building of the clinician, who in turn can then translate that as they see appropriate to the patient. It's not imagined in the health situation, at least, that that would go directly to the patient. Just as clinicians need to be trained, in the example, as to how to interpret an MRI, the algorithms that sit behind an MRI are very advanced image processing algorithms. Indeed, they don't need to know that, but they do need the certification, and the issues that Matthias was talking about do sit around the accuracy, the certification, the oversight, and so on. And for the regulators to feel confident that they can put a certification stamp on an algorithm, they need to be able to probe beneath that, just as the engineers who build the MRI machines need to be certified themselves. So I think there are many layers to the answer.
Thanks very much for that. And it sounds like one of the key distinctions that you're making is between, let's say, something that provides a readout, an image like an MRI might, which is a much more direct sort of input-output relationship, versus something that is producing a recommendation where we probably want to understand, what is happening in the layer underneath in order to trust it. Am I understanding that correctly?
Yes, I think that's definitely one element. I think there's a need to drill into a proposed answer, and that need from a clinician would be very different from the need from a patient.
Mm-hmm. Thanks. Thanks so much, Liz. Matthias, I'm going to come to you, and I want to touch a little bit on what you talked about in terms of these policies that are coming down the pipeline, because that's very interesting. And so it sounds like there's a bit of a roadmap of policies. We're starting to build a picture of what do we want from AI, right? Around explainability, from what Liz, from what Brian has talked about. Now, when it comes to policy, of course, it should play a role to enable us to get those things that we want, of course. If you had the ability to define the policy roadmap for the EU, let's say, around explainable AI, what would be some of the things that you would like to see in it? And what are you sort of learning from the work that you're doing that you think ought to end up in something like a policy roadmap for the EU on explainable AI?
Thanks. Thanks for the question. So I definitely think that explainable AI has to be taught very early on. So any roadmap shouldn't start at the end, right? Shouldn't start at the result of an automatic decision and then sort of work its way back, right? We'd rather have to start at the opposite end. We have to look at the role of AI in society as a societal issue that we have to address on the one hand by education through our schools, through our through all life cycle, all the whole pedagogical life cycle, and secondly, we have to start looking at the whole AI process, and any sound EU policy, any sound AI policy would start asking the very question at the beginning when data to be included in learning data is selected. How does that play into the explainability? How does that play into our tools that we can then use to explain decisions? It's really hard to do that ex post. Dr. Lim has so beautifully described how that can be done, but it's much easier to start from the very beginning and also ask yourself, for instance, so who set up the team that decides on which training data is used? There's always one question that influences how that works out. So my call would be, my ideal AI policy would be one that is much more holistic, that is more societally oriented, and that takes from the importance of explaining and justifying any AI-based decision, that then uses that knowledge, that conviction, to adapt fundamentally how we approach the design of AI systems.
Thanks, and I want to press you a little bit more on that one, because it's such a rich and I think deep area. So I'm hearing education, right? That sounds really key, and early education as well. but who or kind of what types of AI do you think are most critical that we have explained? Do you think that there should be policies that, let's say, insist that certain classes of AI be explainable and certain classes perhaps need not be explainable? I mean, Rita just asked another question around facial recognition technologies, right? Can facial recognition technologies provide meaningful explanations in what they're doing? Or is that perhaps a different class? So are we already kind of thinking about certain categories in which we would like to see an insistence on explainable AI?
Yeah, so absolutely, we will definitely have to categorize. That's the European approach anyway, right? And it's in the AI Act. It uses classes to simplify the challenge of rules of developing rules for AI. So yes, I also think that depending on the impact that a decision has on your life, obviously you'll have different demands regarding explainability. That doesn't change from the offline world, right? Depending on the kind of judgment you get, right? It's either very, very short explanation or a short reason, or perhaps even no reason at all, which is in certain circumstances okay, right? But then if it's an important decision, then there's a long reasoning. There's always has to be a proportionality, between the impact a decision has and your ability to fight against it. Just, one last sentence. There was an interesting case in Germany a couple of years ago when somebody tried to get out of a ticket, a speeding ticket, right? For, I think, 15 euros, so like $16, 16 US dollars. And he wanted to fight that speeding ticket, and the police said, "Well, we can't actually, we can allow you in the proceeding to criticize or to question the AI underlying underlying the mathematical model from which we come to the conclusion that you've driven too fast, because the computer doesn't save all of that information; it just deletes everything, data sensitive, right away." And the Supreme Court of one German land then said, "Well, that's not enough. People have to have the ability to question how decisions are reached, right?" And this is something which I think is an important point to keep in mind. Whenever anybody, any entity, any machine impacts how you live your life, which goods and values you have, then you have to have that explanation provided to you.
Fascinating. Thanks so much. Brian, I want to come to you and hear what your ideal roadmap looks like now, perhaps from a more Asia or Singapore even perspective. I know Singapore's done quite a bit of work in this space, but are there things that you would like to see in, let's say, over the next 3 to 5 years in AI policy? Explainable AI policy, I should say.
Yeah, so thanks. I would consider that at a higher level, every country that's or region that's applying AI would fundamentally try to go to its similar high-level goal. Slight difference in Asia, I guess, is that we are a little bit less sensitive towards privacy concerns. Though, let's say in Singapore, so we're very interested in propagating our techniques to around the world. So the concerns internationally are also highly relevant to us. But without the privacy concerns at the forefront, it does enable more capability development first, right? So one of the first things that we need in to do with explainable AI or AI is to have lots of data and reliable data. In fact, one of the early users of XAI is also to identify, are there biases, or is my data good? The truth is, most likely the data is not good enough, right? So we're still at a stage where we want to use XAI to find out where are the problems in my data and where are the biases in my models, right? So that should be covered first. And then after that, once we have a good process to clean the data and ensure good data quality, right, then we can look into, does the AI reason in a way that the domains that they apply to, that it follows the standards in that domain, right? So I like the medical one because I feel it's a pretty important domain where it's life or death. And the way I look at it is, the doctors understand certain biological processes, not just about variables, but they understand certain processes and causal mechanisms, right? And so the AI should try to reason in a similar way. Extending that idea also, I see explanations as really, it's just one signal to try to understand what's going on in your data. So I do believe that ultimately the human needs to interpret. So whether they interpret it through visualizations, through explanations, or just through rigorous study of their models, they are the accountable ones, right? So here we're looking into how can explainable AI perhaps accelerate that, right? So that the human can compile a reasonable, justifiable, defensible answer.
And so, Brian, just to check two things, and so I make sure I'm understanding this correctly. You're talking about humans and AI partnering to generate explanations, not just the AI generating that explanation. Is that right?
Yeah. So at the level where the AI really has to defend itself, then it should be a human AI partnership. I mean, all the explanations need to be interpreted. And so ultimately, some human has to do it. Of course, I understand there are many applications where you want to automate without the human being present, right? But in the rare case that something exceptional happens, we want the ability that a human can go in and really squeeze out a deep understanding of what's happening.
That's really interesting. And it sounds like a whole new set of careers that will emerge of people whose job it is to work with AIs to generate explanations, which ties to Matthias's point about the early education to make sure that we've got that talent perhaps that is being developed. The second thing I just wanted to follow up on, Brian, is you talked about the differences in, let's say, values around privacy between these two regions, broadly speaking. Does the difference, let's say, does the different threshold for privacy in this region, in Singapore, does it have an impact on explainability, or is it not relevant?
Yeah, so you're asking about whether privacy affects the usefulness of explanations. In fact, some of the research also I've looked into is the conflict between these two requirements. So at a high level, privacy means share less data, and explanation means share more data. So they're going to conflict each other. In fact, we found that if you have an AI model that can explain, there are many sophisticated methods now that can invert a model prediction and then find out the source data, right? So some privacy researchers are demonstrating how easy is it to leak information, even if it's not explicit. So I see here that definitely that this is a difficult thing to solve. One other view we can take also is that we don't need to have automation at every step of the way, or that explanations don't have to be provided to everyone, right? So if, let's say, you would provide explanations to a technical sub-community who are trusted, right, then they can interpret what's going on, and to the public, or perhaps where the adversaries may lie, right? If they do not have access to these explanations, then we still have more privacy, right? But this assumes that we have some authority figure that we are willing to share more data to. And I understand in some countries, even that is not quite so acceptable.
Yeah, that's an excellent point. And Liz, I'd love to hear from you on that, actually. Coming back to the socio-technical challenge, and perhaps socio-technical, political, economic challenge, we've got private companies and vendors to government saying, sorry, our algorithm is proprietary and we can't share it to you. And even if we did, you wouldn't be able to make sense of it. And we have, do we really, or we can, create an explanation, but perhaps it is not actually a genuinely useful explanation. In some cases, these companies are larger than countries' entire GDPs, right? And particularly as we're looking at regions like Southeast Asia, lots of sort of small countries in this region. What do you see as the future for regulating these types of organizations? Do you think we will be able to demand the kinds of, the design of AI that leads to the kinds of explanations that we're hoping to see?
So I think that this problem of super large corporations acting in their own interests as opposed to national or global interests isn't just about AI. We look at tax practices of large companies. We look at the opportunities and challenges associated with cryptography and the hiding of secrets and so on. I think we are starting to see that governments see the importance of working, in some cases collectively, to impose regulation with a variety of penalties that they're able to do. And so I think there's an important distinction between a company being forced to disclose its algorithm at a certain level of detail to a regulator, as opposed to the public in some way. So I think the notion of some kind of in escrow type of layered disclosure to an appropriately trusted regulator, I think will be coming into the future if it's not already, and I'll leave Matthias to comment as to what extent it might already be in play. I think that's the way that will occur, but it will only occur if governments are acting collectively and very insistently, and we've seen mixed outcomes of that so far.
Interesting. So governments acting collectively, as in regional or let's say multi-country partnerships,
Exactly.
aligning AI policies. Yeah.
Yes, indeed.
And Matthias, coming back to you, I mean, the EU is of course an example of this collective action. How's that going? What could we learn, perhaps in the Asia region from attempts to do that collective action? Are you seeing that there are perhaps spoilers in attempts to create the right kinds of EU policy amongst EU members? Are there, important learnings that we ought to take away from the EU experience?
Well, it's a bit difficult to compare, for instance, ASEAN and EU, from the basic legal setup to the political the dynamics. The biggest advantage the EU has is that once it reaches agreement, it passes law that has a direct effect on all member states. So member states don't have to individually subscribe to the law. I think one potential spoiler would be to overcomplicate things, right? To listen to only talk to technological experts, and not also to keep in mind the societal impacts of explainable AI. But I don't see that happening right now. I think that there's actually the whole digital package that EU is right now proposing, from the Digital Services Act to the Digital Markets Act to the Data Act to the Data Governance Act and to the AI Act. I don't have time for my family either. No, that all of that together is a pretty decent package towards a more rights-based international order. The problem which I see is that if I think EU should do a much better job in engaging other regions when it comes to developing those rules, because both with regard to data and with regard to AI, it's not like there's a European data space, a European AI space where we can set the rules ourselves and everybody will automatically subscribe to them. It might work in certain regards. The GDPR, the General Data Protection Regulation, has been rather successful globally, but we're still, I think, sometimes too focused on developing the best rules and not thinking about the impact those rules can have. And sometimes it's better perhaps to be less detailed and more global in terms of how you develop the norms. And yeah.
And Matthias, I just want to touch on also something that I think you hinted at a little bit earlier in our conversation, that there are also rules that are on the books, but they're not implemented, or perhaps they include significant loopholes. Are there learnings around that you think we could, that the rest of the world perhaps could learn from?
Yes, I think that just including, so the norm you're referring to is in the GDPR and the General Data Protection Regulation, where it says that yes, there is a right to have insight into the logic of an algorithmic decision-making engine if that impacts you, if your data is being processed there. But there's also this loophole that says this does not apply if there is a human involved at some point, so it's unique. It's only if it's if there's automated processing. So I think that it is not a good idea to tie the right to explainability for AI decisions, to tie that only to decisions taken only by AI, only by automated decisions, whatever that is in practice. I think that we should at least have a sort of a leeway to say that if an automated decision-making system was substantially involved in a decision, then this already activates the right to explainability. That would be one important message that I could think of.
Excellent. Thanks. Thanks for that. And so as we come to the kind of close of today's session, what I'd like to do is I'd like to just do a round with all of our panelists and hear a little bit about what is kind of one thing that you think we ought to lobby for when it comes to, or encourage our governments to take up when it comes to explainable AI. So for the people who are in the room with us, what's a takeaway? What should I be talking to government stakeholders around or encouraging them to do, or perhaps, if I'm a civil society organization, where should we be kind of taking a stance when it comes to explainable AI? And I think this is particularly, I don't think it's a simple question. I just want to lay this out because it sounds like this area is in its early stages, right? In some ways, it's in its infancy. And so it's difficult to build regulations around things that are in their infancy. But if there was one thing that you think we ought to be pushing for, we ought to be encouraging our governments to take up, what do you think that ought to be? And Brian, I'm gonna come to you first.
So I'll be thinking from a usability and technical approach, and something also raised by one of the Q&A, which is how do we define what is explainable enough? I wouldn't want to say that governments need to set the benchmark for what is considered that, because it varies from community to community and domain to domain. But it is good to set some kind of a framework where different communities can derive for themselves, right? What level of explainability for now, right? That we want to have before we agree that the AI is safe enough for our use case, and that should be something that should be reviewed regularly as the XAI techniques improve.
So if I understand correctly, you're saying we should have a right, but we don't necessarily need to define the specific, let's say, manifestation of that right across all of the different cases because there's so much variance.
But I think also we need to come up with some standards for that. So I guess it's industry or community-driven standards to define what is minimally explainable enough. And hopefully also it can be simulated in a way that companies and institutions want to compete to make their systems more and more explainable over time.
Excellent. Okay, so great. So standards being a great pathway to that. Thanks very much for that. Matthias, how about you? One thing that you think we ought to be pushing for?
I think we should be pushing for more societal engagement. This is such an important question. We need to tell people much more about how AI, the impact of automated decision on society. When I teach my classes and tell them about the role that automated decision making has on, for instance, the way that we communicate online on platforms, people tend to be surprised. If you have the numbers from platforms suggest that between 98 and 99% of all first instance decisions on content regarding ranking, regarding staying online or being put offline are being taken now by automated decision engines. That's huge. And we're not talking about that nearly enough. So I think that already the act of promoting that issue as a key decision to take as a society within the next generation is something which I would think we should all promote. And the second thing is we talk so much about climate change, right? So ecological climate change. There's an agreement this is an important issue, right? I feel that we haven't yet communicated enough that there, apart from ecological climate change, there's also something which we could call political climate change or socio-political climate change. So the changes in the way that we interact with each other and the way that private actors have taken over substantial parts of public discourse. I think that this should also worry us a tiny bit more than it does. And we should ask, we should sensitize people for that and keep the governments a bit more on their toes regarding how they can provide positive reinforcement, more plurality also in private online spaces.
Very interesting. So keeping government on their toes, and it sounds like really this is one of those areas which could sound very technical to people, but we need to develop that understanding so that we can actually have agency over what is happening as a society. Otherwise, it's, you know, decisions are made and it's too late really for us to claw them back. Liz, on your side, what is something that you think we ought to be pushing for?
Yeah, so as with Matthias, I think it's not particularly about XAI. Indeed, it's not particularly about AI. It's about the different ways that algorithmic decision-making is impacting our lives. And not all of those algorithms are particularly smart. But I think we can borrow very heavily from what we have seen is successful in other domains. And if I refer to consumer protection and the production of goods that are safe for people to use, whether it be physical goods like a baby's furniture or car seat protection for passengers and so on. And there, as well as the production of the goods, whatever that might be, we have various ways of asserting the certification and the assurance around the people producing the goods, the quality of the inputs, the processes, and so on. And so we already have a variety of legislative and regulatory arrangements that ensure the safety to the end user of what is they are purchasing or whatever it might be. I think there are many analogies there for how we can structure the appropriate protections, and we are talking about protections. There are, of course, some particular elements about the information economy and the very large platform players that you've talked about. But I think that that recognition that we can borrow from existing frameworks and adapt is one. And I think we also need to put, and perhaps it's a variant of what Matthias was saying, I think we need to put more effort into training end users, whether they be the regulators or the judges or the people directly interacting with what this new technologies do and do not afford. So I think there's, it's easy to just rely on the technologists, and as Brian and in fact all of us have said, including yourself, the technologists are really useful, but they're only one part of addressing the variety of problems. And we need a much more multidisciplinary and multi-layered approach.
Excellent. Thank you so much, Liz. So we've got standards, especially around understandability. We've got awareness for the public. We've got training for the users, so they really understand what they're using. And then we've got this possibility for borrowing from existing frameworks from protection for protection. Regulatory approaches around this that are existing, already used to protect us against other kinds of challenges. So I want to thank, this brings us to the end of today's session. I really want to thank our three panelists for joining us. So we have Professor Matthias Kettermann, who is the head of research program at the Hans-Bredau Institute in Germany. We have Professor Liz Sonnenberg, who's the Pro-Vice Chancellor for Systems Innovation at the University of Melbourne, Australia. And of course, we had Dr. Brian Lim, who's Assistant Professor of Computer Science at the National University of Singapore. Mostly, I also want to thank everyone who has joined us for this entire conversation. As I mentioned at the very beginning, this is part of a series of webinars on this debate around AI and explainability. Our next session will be on the protection of data rights for citizens and users. That is coming up in mid-June. So look out for that, and we would love to have you as part of that session. Tina, I think our colleague Tina has pasted a link into the chat for you to join us there. But otherwise, thank you all for joining, and I'm wishing you a wonderful rest of your day.